Okay, so there was a request to show how to do this lab if you missed a class, if you missed the data. So this is the ball on the floor lab, and I'm going to show it to you as if you were not here to collect any of the data in the class, so that you can complete it. So as usual, you go to our Canvas page. This is the home page. Now you always scroll down to whatever the date is. So today is the 18th. This is the day I'm making this. And this is the day that the ball on the floor lab is due. So I'm going to click on that. And that brings us to what we're doing today. As usual, you would do your due now as you come into class. And then there is what we're doing in the class. And here is the links to all the class work. I'm going to put this video down below here just to help out. I'll add that after I make the video, of course. So there's two things that you need to open. One is the ball on the floor lab. And the second one is the Desmos, which is assigned to your period. So the ball on the floor lab, you're going to click this and you're going to open up a Google document, which is going to look very much like this. And you can see I've kind of got one that I was using with the class where I put my name. So put your name in that point. Right here, the ball on the floor, how far did it travel in 6 seconds? We did that as a class as well, where you put in a guess. How far do you think the ball will roll in 6? It's a wild guess, so you put whatever you need to put into that. Your manipulated variable and responding variables. As you can see, once again, we did this as a class. The distance that the ball roll is the manipulating, the things that we're changing. The time that the ball roll is the responding variable. With this right here, you have a graph that we edited in class. It should show up blank in yours, but if you click the word edit, you open up this thing that says drawing and click this thing that says line, and you can draw a line how it's supposed to look, and then you can get that. And I'm going to delete that because that's not what I want on there. So you should have something that looks like that, and that's just what we logically worked out. We put that into words. If we did this, if manipulating variable, then this would happen, the responding variable, and then explain why. So something along the lines, if we change the distance that the ball rolls, then it will take longer for it to roll because of the time it takes for a ball to reach each destination. Something along those lines. This was the instructions that we used to do the lab in class. If you weren't here for this part, I'm going to show you in a moment what you need to do to make up for that. I'm going to pause on this screen for just a moment so that you can actually, what you can do is you can pause your video so you can record what your data is. And then here, and you can see this is not accurate and it's incomplete because I was using it as an example. This is the data that you were supposed to gather with your group. So if you got this with your group, you just got to figure out the averages, your average times that the ball rolled for these distances, and you would put your times down. We had the low ramp where you guys recorded the times, and then you had the high ramp where you guys recorded the times. All right, from there should be two graphs in this graph area, one for the high ramp and one for the low ramp. I'll show you how to put that in there in a moment. The slope, that is going to be in your graph. It'll tell you what your slope is. I'm not revealing what mine is because I don't want you to copy what mine is. I want to see what yours is. The equation is also given right there. Distance equals a times time. I'll show you where that is in Desmos in a second. And then conclusion. This is not actually part of the assignment right here. That's just a helpful hint on how to do it. And then the conclusion, you're filling in the blanks here. My suggestion to everybody was go back and look at the pendulum lab. If you weren't here for the pendulum lab, go back and look in Canvas. Go to modules. And within modules, you will see that this is everything we've done every day this year. Go back to where it says Pendulum Lab. There's the Pendulum Lab right there, 3.3. And open up the Pendulum Lab notes. And there is a good reminder on slide 20. This is how we answered the pendulum lab. There's these parts of the conclusion on slide 20, and slide 21 is how we did it. So you could actually use that to help you to answer, fill in these blanks for claim, evidence, prediction, so forth and so on. For the confidence level, you're going to use the chart, which is right here. If all the data lines up, then you have high confidence. If they're scattered, you have medium. If they're hard to find where the lines should go, that would be low. If where you're predicting is within the data, then that would be high. If it's just outside of the data, that would be medium. If it's way outside, that would be low. So you would match how the data matches up with the lines versus where the data is at. You would determine where it was at. So if it was like the data was off of the lines and we were way away from the data, I would say that would be a medium low confidence with my prediction. And that's what I would write here. All right, so how do we get this data? All right, how do we get the data, especially if you weren't here in class? If you weren't here in class, to get this data right here, we're going to go back to Desmos, and I'm on the wrong screen here. You can actually just go ahead and skip over slides 1, 2, 3, 4, and go ahead and go to slide 5. And here we have a video. There's two videos. There's the low ramp video and the high ramp video. You're going to be doing both. Okay, with the low ramp video, you're going to play the video, and you're actually going to pause. I'm going to pause the video right here, and you can see where the ball right here is. It says 0.5 meters and 1 meter. You can scrub, which means move the video. And you can see at 1 meter, it's going to be 0.6. So over here where it says distances, you can see it's going to go 0, and then 0.5, and then 1.0, and then 1.5, and then we'll just go ahead and, one more whoops there, 2.0, all right? This data right here is going to be worthless. Okay, so we can see that at 1 meter, it's 0.66 seconds. So at 1 meter, I would type in 0.66. All right, I'm going to scrub to go back to 0.5 meters. And at 0.5 meters, it looks like it's at 0.33. All right, I'm going to scrub it and go to 1.5 meters. You can see it's 0.93. And I could do all of this for you because you need to do some of this on your own. So you can go ahead and figure out where it's going to be at 2 meters. All right. You're going to hit next. And that's going to bring up a graph. Now, with this graph, you notice that there's no lines in this graph. This is your data. The box represents the uncertainty of your data. So you want to draw a line that matches your data as best as possible. Now, you see my dots are a little bit off, but it looks like this red line right here. That's the one that matches my data the most. The green line doesn't work at all. The blue line doesn't work at all. This purple line doesn't work at all. So you can come over here and you can delete the blue line. I don't need the blue line, right? I'm going to delete that and get rid of it. I don't need the green line. I'm going to delete that. I don't need it. The purple line, I'm going to delete that. I don't need it. That leaves me just the red line, all right? The red line matches up almost perfectly with my data. It's pretty close. That is a little bit off. I can try to wiggle that line a little bit. Now notice that as I'm wiggling the line, this A equals, that changes. That is the slope of your line. The formula for that or the formula for this line, to make this line happen, is d, which is your y-axis, your distance, equals a, which is the constant, and that defines what the slope of the line is, which is going to be 1.6, times t, which is your x-axis, time. So right here where it says write mathematical model, this is your mathematical model right here. So you're going to scroll down a little bit, and I can't write on this, but what I can do is right here, you see it's written in purple, and it says XY right here, write mathematical model. You're just going to highlight that and delete it, and type what the mathematical model is. Distance equals a times time. And then I write off to the side here a little bit so that I know what it is. A, for me, is equal to 1.6. Close parenthesis. I said A equals 1.6 because that's what it says right here. A equals 1.6. So it would be distance equals, oops, I made a typo there, equals A times 1.6. And that'll show up right here automatically. The next thing you need to do is you use a snipping tool. If you've never used a snipping tool before, unfortunately it doesn't show up on the screen, but there's a little search bar right here. You click on that search bar and you type the word snip in there. And it brings up a little program in Windows called the snipping tool. And it looks like it's thinking. It looks like this right here. What you're going to do is you're going to click New. And you're going to left click, hold down, and drag. You notice it all went gray there, and now it's highlighting the area that I want to put into my lab, the thing that I'm grading. So I highlight that, and there we go. Now we have a graph to kind of deal with. If I go up here, I can go to Edit and copy it. So now I've just copied this graph. I'm going to go back to the main lab, the Google Doc. This is the thing I'm actually grading. And this is where you're supposed to put that graph. So I told you there should be two graphs. So my second graph, I'm just going to put right here. You can right click and paste, or you just hit Control V, and there's my graph right there. So when I'm looking at this, I should see two graphs, one for the high ramp, one for the low ramp. So you're going to make this graph. That was for the low ramp. You're going to make another graph for the high ramp. So you can do this whole thing again, where you measure your times. You know, scrub up the videos, and these numbers are going to change, and then you're going to go back and you're going to, this graph will look different. You'll adjust your A there to match what your new data would be, and you would use that snipping tool and you would put it in here, so you would have two graphs. Okay, from there, your low ramp slope, that is what you put in the parentheses right here. So that would be A equals 1.6. So you would put A equals 1.6. If you've got an older copy of the lab, it might say C equals. I told the class to change that to A. Okay, what is the equation? Well, the equation would be distance equals 1.6, that's what A equals, times time. So you would write distance equals 1.6 times time for the low ramp. And then for the high ramp, you would put what that equals there too. All right, from there, it's just basically you go in here and you insert, using the sentence structure, you insert what you observed, what you predicted, and what your confidence level is within this conclusion. At the very end of this, you can go back to Canvas. If you're complete with it, you can hit Submit, but don't hit Submit until you're absolutely done. That's just telling me to grade it. You can close it out, and it will come back up with whatever work you had on it before. So I hope that's helpful. Remember, it's due by midnight on October 18th. I tell you what, I'm gonna stretch that. I'm gonna say by midnight Friday of this week, which would be the 21st, I believe. So this will be due by the 21st of Friday. All right, good luck, everybody.